Hey folks, haven't you always wondered what nuclear radiation is?
I have!
Well, you have now. This is 4-Minute Physics.
Yay!
Before we begin, let's just look at a few of the basics. This here is Earth, and it is made up of trillions and quadrillions of tiny little particles known as atoms. Each atom is made up of 3 subatomic particles: the proton, the neutron, and the electron. The proton and neutron make up the nucleus, while the electron orbits outside. Atoms come in many different forms, or isotopes. Take hydrogen for example. Hydrogen 1, the normal hydrogen, occurs normally in nature and is fully stable. Hydrogen 2, or deuterium, occurs much more rarely, and though it does share a few traits with hydrogen 1, is highly toxic in large concentrations. And then, finally, there's hydrogen 3, or tritium. Tritium, which has 1 proton and 2 neutrons, is highly unstable, and if one was to leave it in a container for over 1,000,000 years, would slowly turn into helium-3, with one neutron becoming a proton, would leave it fully stable. This transformation is known as radioactive decay. Now you might all be thinking, Raj, that obvious information is great and all, but just what does it have to do with radiation? Well, don't worry, excited viewer, we're almost there. But first, we'll have to take an in-depth look at the idea of radioactive decay. And Mr. Khan Academy has done that for us very well.
We're zoomed into the nucleus. And so it turns out that sometimes the nucleus is a little bit unstable, and it wants to get to a more stable configuration. Into a more unstable nucleus, sometimes it emits what's called an alpha particle, or this is called alpha decay. It's an alpha particle, which sounds very fancy. And it's just a collection of neutrons and protons. So an alpha particle is 2 neutrons and 2 protons emitted. They leave the nucleus. Alpha particle is really just a helium ion, a +2 charged helium ion that is spontaneously emitted by a nucleus just to get to a more stable state. Now that's one type of decay. Let's explore the other ones. So that a neutron doesn't feel comfortable with itself. It wishes that it looks at what the protons do on a daily basis and says, you know what? For some reason, when I look into my heart, I feel like I really should be a proton. If I were a proton, the entire nucleus would be a little bit more stable. And so what it does is, to become a proton, remember, a neutron has neutral charge. So what it does is it emits an electron, and by emitting an electron, instead of being neutral, now it turns into a proton. It turns into a proton. And so this is called beta decay. And a beta particle is really just that emitted electron. So there's one last type of decay that you should know about, but it doesn't change the number of protons or neutrons in a nucleus, but it just releases a ton of energy, or sometimes a high energy photon, and that's called gamma decay. And gamma decay means that these guys just reconfigure themselves, maybe they get a little bit closer, and by doing that they release energy in the form of a very high wavelength electromagnetic wave, which is essentially a gamma. You could either call it a gamma particle or a gamma ray.
Along with gamma decay, there is also something known as spontaneous fission, where an atom, instead of throwing off an alpha or beta particle, actually splits to create 2 new atoms. For example, a heavy atom like fermium-256 might undergo spontaneous fission when it decays and turn into xenon-140 and palladium-112. And in that process it will reject 4 neutrons. These 4 neutrons, described as prompt neutrons by the Argonne National Laboratory, can either be absorbed by other atoms and cause nuclear reactions, such as decay or fission, or can collide with other atoms and cause gamma rays to be emitted. These neutron radiation can then be used to make a non-radioactive atom radioactive, which has many practical uses in nuclear medicine, nuclear energy, and the study of subatomic physics. In many cases, a nucleus that has undergone alpha decay, beta decay, or spontaneous fission will be highly energetic and therefore unstable, To eliminate this extra energy, these atoms produce a gamma ray, which is an electromagnetic pulse that is like an X-ray and can penetrate matter. These rays are made up of energy and are highly, highly dangerous and constitute a major source of radiation. All of these radioactive decay emissions are known as ionizing radiation, meaning that when these rays interact with an atom, they can knock off an orbital electron. The loss of an electron can cause problems, including anything from cell death to genetic mutation. Still, the matter penetration strength of all these particles varies greatly. An alpha particle can easily be stopped by something of the magnitude of a piece of paper, while a beta particle fares only slightly better and cannot go through something of the magnitude of a human hand. A gamma ray, on the other hand, is extremely powerful, and it would take something of the magnitude of a large concentration of lead to fully stop its spread. As our understanding of radioactive decay has improved, so has our ability to make use of its many emissions. Gamma rays in particular have many uses, including with X-rays and neutron bombs. Radioactivity is in both its man-made and natural forms is extremely powerful and has had a large effect on our modern world. Just remember, if you ever encounter any without proper protection, just follow Bert the Turtle's advice saying,
He's duck and cover, duck and cover. He did what we all must learn to do. You and you and you and you.